On to assignment sheet 3 in unit 2-8 series circuits. In question number 1 on assignment sheet number 3, we're asked to solve for EA, the applied voltage. Okay, we're given 2 bits of information here. This ammeter is telling us we have 2 amps flowing in a circuit, and this label on the resistor is telling us that we've got 20 ohms of resistance. So we can use what we learned about Ohm's law. E is equal to I times R, and we'll substitute in then EA is equal to I times R1. I is 2 amps, and R1 is 25 ohms. So that means the voltage EA is equal to 50 volts. Now the next question is similar. We still have 2 amps, but now we got twice the resistance, 50 ohms. And I see you came up with an answer of 100 volts, which is double what you had up here. Same current, twice the voltage, or resistance, twice the resistance. Using Ohm's law, E is equal to I times R. EA is equal to I times R1. I is 2 amps. R1 is 50 ohms. So that means E applied is equal to 100 volts. Just as we thought. Okay, let's go down to number 3 here. I see you've got to answer 40 volts. That would be the right answer if the resistance here was 10 ohms. But it's not. It's 10 k ohms, or kilo ohms. So R1 equals 10 k ohms. Let's convert k ohms to just ohms. How do we do that? We move the decimal place to the right 3 places. So 10, put a comma there, 3 zeros over 3. So it's 10,000 ohms, or 10 kilo ohms. Okay, if we want to calculate EA then, EA is equal to the current times R1. The current is 4 amps. The resistance, 10,000 ohms. So that means EA is 4 times 10,000, or 40,000 ohms. If we want to convert that back to kilo ohms again and get rid of some zeros, we can say that's equal to 40 kV, 40 kilovolts. Okay, let's go on to number 4. Number 4, they want you to once again do a similar thing. Figure out EA when you're given the current and given in the resistances. These prior circuits were all pretty simple. They only had 1 resistor in it. Now we've got a circuit with 2 resistors instead of 1. And Dennis put a hint down here. Resistances are additive. So what he's wanting you to do is simplify this a little bit and say, okay, EA is equal to I times RT, total resistance, or total opposition to current flow. What's the total opposition to current flow in this question? RT, or total opposition, is equal to R1 plus R2. R1 is 20 ohms. and R2 is 30 ohms. So RT equals 50 ohms. So now we can go back and use Ohm's law to figure out what the applied voltage is using total resistance. EA equals I times RT. What's the current? 20 amps. What's the total resistance? 50 ohms. So if we want to go ahead and calculate that out, then we're going to say 20 amps times 50 ohms is 1,000 volts. Or if we want to convert that to kilo ohms, then we can move the decimal place one place and we can say it's equal to 1 kV. Okay. Looks like we got a couple left to go here in assignment sheet 3. Same type of thing as the one before us, all he did was add another resistor to it. So he says solve for EA. Instead of 2 resistors, we've got 3. We got R1, R2, R3. We know what the current is. So we know we can use Ohm's law to figure out what EA is. EA is equal to I times R sub T, or total opposition and current flow. What's the total opposition and current flow here? Well, we can just add up the resistors in series to get the total. So RT is equal to 120. Well, let's just write that out symbolically first. RT equals R1 plus R2 plus R3. Okay, what's R1? R1, 120 ohms. Plus R2, 20 ohms. Plus R3, 10 ohms. So what's that come out to? 120 plus 20 is 140, plus 10 more is 150. RT is 150 ohms. So now to figure out what E applied is, then we'll just use Ohm's law. EA is equal to I times RT. Current 2 amps times total resistance 150 ohms. So that's 300 volts. EA equals 300 volts. Okay, number 6. We're down to the home stretch here. Solve for EA. We've got 20 milliamps, and that flows through a resistor of 2 k ohms. K ohms, remember, is kilo, which is 1,000, so that means you got 2,000 ohms. Here you've got 3 kilo ohms, or 3,000 ohms. And now he says here you have a milliamp. What's a milliamp? A milliamp is 1,000th of an amp. So that means what we have here is 20 thousandths of an amp that flows in this circuit. The way to convert milliamps to amps is move the decimal place to the left 3 places. So if we've got 20 milliamps and we move the decimal place, here we go again. Let's get rid of that. We got 20 milliamps. If we want to convert milliamps to amps, we move the decimal place 3 places to the left. 1, 2, 3. put the decimal place there, and we got to put a 0 in front. So 20 milliamps is actually equal to 0.02. 0.02, I wrote milli here. I didn't really mean to do that. 0.02 amps. So we know we've got two resistors here. We know we can add those together, get a total resistance. I'll work that down here below. RT is equal to R1 plus R2, and that's equal to 2,000 plus 3,000 equals 5,000 ohms. Okay, so now we can use, here we go again. Let's get rid of that. RT equals, okay. EA is equal to I times RT. I is equal to 0.02 amps. RT is 5,000. So if we want to multiply that out, then 0.02 times 5,000 is 100. So EA is equal to 100 volts. Okay, well that does it for assignment sheet 3.